Hello, this is the video for the data mining course, and I would like to continue about the section of data warehouse. And I guess we already finished with the first part of the data warehouse. I'm going to continue with the second part, which is about the data cube and OLAP. So if you still remember, we are dealing with the OLAP. OLAP means the online analytical processing. And we have the OLTP, means online transaction processing. So in this chapter, we are going to learn about the data cubes. I'm expecting you already took the database class. But if you don't have the basic about the database, yeah, I'm suggesting you to review a little bit about what is database from other resources. Yeah. And for this one, I would like to mention again about the data warehouse. So in the previous video, we learned about the data warehouse, and this data warehouse is based on a multi-dimensional data model. So you already know that we need to collect the data from multiple sources in order to make it as a data warehouse. So there are multi-dimensional data for the data warehouse. The data cube means we are going to see a particular table or a particular information. Let's say if I want to focus on sales. So the data cube allows data to be modeled and viewed in multiple dimensions. So usually there are two kinds of data. There are two kinds of cubes we can see. First is about the dimension tables. The dimension tables means we are having the item. Okay? So the item means like the item name, item brand, and then the type. Yeah, everything about item can be in one table. Or time. Yeah, so time can be regarded as day, week, month, quarter, year, or for example, supplier. Okay, supplier can be also one of the dimension tables, like the supplier name, supplier address, supplier ID, and then etc. Okay, so those kind of tables we call it as the dimension tables. And there is another dimension that we need to understand, which is the fact table. Fact table means something related with the transaction. Okay? Something is the real one. Maybe in the Korean word we call it sasil. Okay, because sasil, yeah. So the fact table contain measures. For example, how big is your revenue, or maybe how big is the transaction cost. Usually, if you are dealing with the dollars, okay, yeah, it can be dollars sold. Or if you are in Korean, it can be related with the transaction in Korean won, for example. And the fact table usually will have keys to each of the related dimension tables. So the key will be regarded as for example, the supplier ID or the item ID or the time. So in data warehousing literature, we have the ND base cube. So N means any number, any integer number with regard to the cube, and then it is the dimension. Okay? So if we have 3 attributes, then we can have 3D base cube. If we have 4 attributes, then we have 4D base cube. Okay. The top one, we call it the 0D. And the highest level, we call it the apex. Okay. Oh, sorry. The 0D is the apex. Okay. So we will see the example later. And we will check this on the lattice. So lattice means the structure, the hierarchical structure of the cube. So before I explain those lattice, First, let's see. This is the intuitive example. How we can construct the data cube. Let's suppose I have a daily transaction. Okay. So this is the transaction one, and then this is transaction two. In the transaction one, Honggildong. Okay, I think this is the most common name. Honggildong purchase LG TV 45-inch at Yongin brands in 2020 January 4, and he paid 500,000 won. Okay, the transaction 2, Iljime purchased Samsung refrigerator 850i at Pundang brands in 2020 March 7, and she's paying back isip Oman won, or 1,250,000 won. Okay, so from this information, what actually we can see is about the sales. Okay, so the first sales is the T01 is the transaction. The transaction 01, the customer name is C01. So we just collect the ID. The ID here is the Hong Yildong. Okay. So Hong Yildong has DOB. This is date of birth. Okay. Date of birth means the Sangil. Yeah. And then is this address. Address means where is he live. So let's say he live in Mohyun. And we know that he bought the LG TV 45-inch. So the item is I02. I02, you can see the I02 is this one, LG TV 45. So the I02 is only the ID. It means I do not need to put all the details in the table. So I just need to call the ID of customer and then the ID of the item and then the location. So location, you can see here, the location he bought the TV at Yongin. So Yongin brands here, L01. Okay. And what about the date? The date was in 2020, January 4. And then the amount is 500,000 won. Okay. What about transaction number 2? In the transaction number 2, yeah, the C number 2, which is Iljime, and then the item is I01. Okay, I01 is the refrigerator, and then the location is L02 because this one is in Pundang branch. Oh, okay, this one L02, and she bought the item on 2020 March 7, and she was paying amount as 1,250,000. So those kind of information, it can be regarded as one cell. Okay, so this is one cube, and the cube is something related with the location and the time and the item. So here we have the time. This is the time, and then this is the location. Okay, and then this is the item. So if you want to add more for the customer, then there will be another dimension. So this is already in the 3D. Okay, this is only in the 3D, or I just want to represent the 3 attributes. And you can see that if we have only 3 attributes, yeah, we can represent the data like this kind of cube. So we call this is the sales cube. So one cube can be represented with regard to the location, time, and the item. Okay. So each cells contain the sales amount for a specific item at specific location during a specific time period. So for example, I want to see the total sales of LG TV 25 at Yongin brands in March 2020. Okay, so specific item, specific location, specific brands, and specific time. That's called as one data cube. So each dimension may have hierarchy. Okay, so this will have a different issue later. Let's say I have the March 2020, but actually there will be a hierarchy. I can make it down, like I want to know the sales on 20 March, or I want to know the sales on 10 March. So it means it will be a time unit is very small, which is day. Or you want to see it in the respective year, then you want to see only 2020. That's also fine. Okay. Then I can say that this is a kind of lattice. Okay, what is lattice? So lattice is this kind of combination between the four attributes. So we have the 4D. Okay. So the 4D, it means the four attributes for what we want to see. We have time, we have item, we have location, and then we have supplier. And what we call this one as the base. This is 4D base cuboid. If it is 3D cuboids, then we can have this we have four possibilities. Okay, we have four possibilities. The first is time, item, or location. The other is time, item, supplier. The other can be time, location, supplier. And the other can be item, location, supplier. So those are the combination from the four attributes. And we just want to see the three relationship between those attributes. And after you have the three, you will go to the two cuboids. The two cuboids means you want to see the relationship between two attributes. So it can be time and item, it can be time and location, it can be time and supplier, time, item and location, item and supplier, location and supplier. Okay, and the last, we can see only one dimension. So we know that the dimension are the item, time, location, and supplier. And the top, okay, the top will be the 0D, or the apex. We call this is the 0D cuboid to represent the all things that you want to see. So those this overall we call it as a lattice, and this relationship will show you how can represent the 4D, 3D, 2D, 1D until the 0D. So the n, okay, n means the number of variables that you want to check. Okay. In the data warehouse, there is a conceptual model that you can refer to. So in this conceptual model, I would like to explain only three. We have a star schema, we have a snowflake schema, and then we have fact constellations. What are they? So the star schema means the fact table is in the middle, and it is connected to a set of dimension tables. The snowflake schema is the refinement of star schema. So do you still remember the fact table? And do you still remember the dimension tables? Yeah, so if you see the previous one, yeah, this one, dimension tables and the fact table. The dimension tables is only to represent what is the item, what is the time, what is the location. Okay? And for the snowflake schema, we have the some dimensional hierarchy. So we will see some dimensional hierarchy, and then it is normalized into a set of smaller dimension tables. So I will show you the example. Okay, and what is fact constellation? Fact constellation means we have multiple fact tables, and it is the dimension tables. We can say that the fact constellation is a collection of stars. So there will be a lot of stars. And we call it as the galaxy schema. Okay, what is galaxy schema? Yeah, we will see that one. So this is example of the star schema. We have the fact table. The fact table is in the middle, and the other table is the dimension table. Dimension table, dimension table, dimension table, and dimension table. For example, we have the sales. So the sales fact table, we have the time, and then we have the item, we have the brands. Let's say, yeah, we have the location of the customer, and how many items that you sell, and then the amount that you sell, and the average sales. For example, we call this is the measures, and this is the brands, and then this is the time. So the time can be like the day of week, month, quarter, and year. And the item, we have the item key, the item name, brand type, and supplier type. And then I have the location. It's regarded with the location key, street, city, state, and country. So I do not want to put all the thing in the sales fact table, because the sales fact table, like what we already did before, yeah, this sales table is only to capture the key. So every table that you already have in the dimension tables, you don't need to put all the information in the sales table. You don't need to put the Honggyeodong. You don't need to put the date of birth. You don't need to put the address, because all of them can be get from the ID. You can get from this ID. Okay. So in that case, the sales table is the fact table. Okay. So this is the fact table, and this is the fact table, and the other table we call this is the dimension table. Okay. In this case, the sales fact table is the fact table, and it is related with the other schema, with the other dimensional tables. So we have this is the time, the time item, okay, time item, and then brands, and then some measures and the locations. What about the snowflake schema? In the snowflake schema, it will be more complicated. So the fact table is in the middle, and it will have correlation with the dimensional table, but the dimensional table will have another sub-dimensional table. It will have another sub-dimensional table. The same with this one dimensional table will have another sub-dimensional, will have another sub-dimensional. So in this case, if you have a sales fact table like this one, it connect to the time, okay, the same, like we have the brands, we have like the item, but the supplier key, okay, for example here, I know that this item is an item with a particular brand and with a particular type, and there is a supplier for this item, and this supplier will have another kind of table to indicate what is the supplier, who is the supplier, where is the supplier, and yeah, any other information about the supplier. The same with the location key. Let's say this is the location of the customer. So the location key, yeah, and then I can know about the street and the city key. So the city key means, for example, Yongin. Yongin has a kind of city key, or let's say we have the postcode, okay, zip code, and then based on the zip code, yeah, I can directly know about the city name, the state or province, for example, Gyeonggi, and the country here in the Republic of Korea. Then, yeah, those kind of things, we have not only one dimensional table, but this table will have another connection to the other table. This will have connection to other table. Okay. What about fact constellation? So for the fact constellation, it is more about the connection with more than one fact table. So the fact table that we saw before is only about sales. How about if we have another kind of fact table which regard to the shipping? After you receive the sales, of course, there will be some options. For example, you need to deliver the product to the customer. Then we will have the shipping fact table. It will show you the same, like the time when is the shipping time. And again, we will have the item, what are the shipping items, and the shipper key. So for example, the brand key is in Yongin, the shipper is another company, not from the LG, but the shipper is from Lotte, for example. Then you will see that this information will connect to another table or another dimension table. Location, we have the from and to. For example, it is from the Yongin branch to Mohyun. And the dollar cost and the unit ship, it is related with the transportation cost. So we have two fact tables, okay, and then those two fact tables are correlated with the other dimensional tables. It is correlated with time, with item, with brands, measures, and location, and as well as the shipper. So those kind of connection, we call it as the fact constellation or galaxy, because we have one star, okay. So this is one star, and then we have another star with this one, okay. So multiple stars in the same structure, we call it, this is the galaxy or fact constellation, okay. We call it fact constellation. So if we are dealing with the location, we can have the concept hierarchy. I think we already discussed this one a little bit from the previous section. So if it is the street, okay, and then it goes to the city, and then it goes to the country, and then it is going to the continent, and then it is based on the world, okay, the earth. So the data cube measures, if you see from the previous one, we have the measures, okay? So basically the measures are like what you already learned from the basic statistics. And there are three measures in the data cube based on the literatures. We call distributive, algebraic, and holistic. So distributive means we want to apply the function to n aggregate values is the same as that derived by applying function on all data without partitioning. So without partitioning, we can just do the count or sum or minimum or max. Let's say this one. I have the row 1, I have row 2, and then row 3, and then I have row 4. Okay. In the row 1, I have the column 1, column 2, column 3, like this one. And for the distributive, we can just calculate the minimum. For example, we can just call the count. The count means how many items? 1, 2, 3. Okay, we have 3. And the minimum is the value here. The minimum is 1. We have the minimum is 4 here. The value is 4. And then there are 2. Why do you have 2? Okay, NA means not available. So it is a missing value. And the R3, we have the 1008 and 2. So we have the minimum is 2, and then the count is 3. And the R4, we have the minimum is 5, and then the count is 2, because 1 is missing value. Okay. What about the algebraic? So the algebraic means I want to compute with an algebraic function with m arguments. So m is the bounded integer. let's say we have this bounded integer. I want to just calculate the average. Okay, so this average is based on the bounded integer from 7 and 5. It will not consider the NA. What about this one, the R3? So the R3, we have 1008 and 2. So the average is 505. Okay. And what about R2? It is 4 plus 6 and divided by 5. So yeah, the result is 5. So this is the simple algebraic function. Or you can also measure the standard deviation. Holistic. So the holistic means you want to find more information and there is no constant bound on the storage size needed to describe the sub-aggregate. Let's say I want to know the median. Okay, you know that in the average is not representative, it's not holistic, because you can see the result here 1008 and 2. Okay, the gap is very high. If you do the average, you will get the value 505, which is not holistic, which is not a representative value. The other average is very small, but only this one has a very big number. Therefore, we can use median instead of the average. We call the median as the holistic. So the median is 8. It means we can just use the value in the median or the 50% quantile to represent something in the middle. Yeah, we don't need to get the average because there is an outlier, because this is the outlier. The same as well with the column wise. Okay, the column wise, we can see that the average is also high in the respective numbers because of 1000. So we can just use the median. So the median here is 4 plus 7 divided by 2. We can also use the mode and rank in order to find the holistic number. Okay, so there is the mode. It can be used for the categorical data. Rank is also, yeah, we can use with some measures for the numerical and also for the categorical data. This is one example, okay, for viewing the warehouses and the hierarchies. Let's say we have this one is the, okay, where is this? This is the date, the price 1, price 2, okay. And this is the in the Vancouver, there are multiple customer. Okay, Charles Dunham, Harry Crane, Kelly Gregson, and so on. So those are the maybe this is the representative name, I guess. So you can see here, yeah, we can have the representative name, we can have the branch name, we can have the country name, and we have the region. Okay, so those things can be seen in your data warehouse. And also in the data warehouse, you will see those as the multi-dimensional data. Let's say the product, okay, the product, what you see before is the LGTV, okay, LGTV, and then you will see a specific inches, for example, 45 inch. Okay. What about the category? So maybe the category is electronic. Okay. And yeah, there will be another product in the electronic which is not TV, for example, refrigerator. Okay. So there is a refrigerator. Okay. And this reference is also regarded the electronic. So it means the electronic can have many items. And yeah, once you are dealing with this electronic stuff, then you will have another, for example, the industry. What is the industry? So maybe this is about the electronic industry, for example, yeah, just LG. So because this LG is we have TV, we have and then this product is electronic, and then this is LG. And as you know, the LG sells not only the electronics, maybe yeah, you want to relate with the groceries. Okay, so the groceries from the LG, it can be also the category, and then you will see another item, for example, shampoo. Okay, so this yeah kind of things is a kind of hierarchy from the product level until what is the industry. Or you can see from the region, the office. For example, the office is in Mohyun, and the Mohyun is in the Yongin city. Yongin is in the Korea, and then the region is maybe about the Asia. And then the day, it can be regarded as the week or the month, and then we have quarter, and then we can have the year. So those hierarchy available in your data. This is one example about a data cube. Okay, so we have the product, and then we have the country, and then we have the date. So every of these data, we have the sum. Sum means the total. So the product is VCR, PC, and DV, and then this is the summation. And then for the date, we have the first quarter, second quarter, third quarter, fourth quarter, we have the summation. And then the country, we have the USA, Canada, and Mexico, and we have the sum. Okay, so the total will be here. It is the all plus all plus all. So the all here plus all will be added to this, and we can see all the values here. So if it is in the latest one, right, this is what we call as the latest. Okay, this latest will show you the relationship between those attributes. We have three, which is product, date, and country. Okay, we have product, date, and country. Then only three attributes. So we call it, this is 3D, or this is the base cuboid. So the base cuboid, which is 3D, if you want to see the 2D, then you can just see that there's two attributes, product and date, or product and country, or date and country. And then if you want to see the 1D, it's product, date, and country. And the other is, yeah, the last one is about the apex. So the typical OLAP operations, yeah, if you already have your data warehouse and you know about the hierarchical stuff, we can separate the OLAP operation into 5. The roll up, which is the name of the summarization of the data. So it is climbing up or hierarchy by dimension reduction. The other is drill down, okay, down or up. Okay, we call it this. You can also call this roll up or drill up. This can be drill down or roll down. Okay, so it is the reverse of roll up. The drill down from the higher level summary to the lower level summary, or usually, yeah, we want to see the detailed data. There is another operation, we call it slice and dice, pivot, and other operation like drill across and drill through. Okay, so I'll show you some example about this one. Drill up. What is drill up? So drill up means I want to see some location, and I want to go to the upper level. For example, I want okay, this one is the city name: Florence, Venice, Nice, Lyon. Okay, so those are the cities in Italy and France. So if I drill up, it means I want to see a bigger level. That is the country. Maybe in Korea you have like Busan, Daegu, Daejeon, Seoul, And if you want to see the overall values, then you can just wrap up everything, roll up, and then you want to see from the country, which is Korea perspective. Drill down, it means I want to see in the opposite one. So I have the information about the lion, sorry, I have the information about the season. Okay, so I have the information about the season, let's say winter, spring, summer, and fall. So if there are only uh, four level of the time of season, I cannot see the detail. For example, I want to know in January. So we will just do the drill down. It will drill down into month. So January, February, March, and so on. Okay. It means I want to know more detail. What about slice and dice? So slice means I'm using the time winter. Okay. So I just want to slice for the winter only. Okay. So I want to see winter only. Then I just slice. Okay. I just want to capture only winter, and spring, summer, fall will not be included. What about dice? So dice, it means I want to make a particular condition. So location, I want to see in the Venice or Florence. And the season, I want to see winter. And I want to see only about clothing. Okay. So the result of dice, dice. So dice is, yeah, some kind of the subset of this data warehouse, and it will be the slice from the the other perspective. Perspective. Okay. So if you have the season, components, and location, then those three perspectives will have the condition. Pivot. So what is the meaning by pivot? In the based on the definition, we want to like rotate. Okay? So we want to rotate the information like this one. If I have Chicago, New York, Toronto, and Vancouver, and those are the items: mobile, modem, phone, and security. So if I pivot them, then it will be like change the matrix, or we call this in something with the transpose. Okay, in a matrix we call this is a transpose. So this was belong to the row and now belongs to the column. Okay, and what about the other, about drill across and drill through? So drill across, we want to see, this is not in the English one, but this is the product 140 and this is product 252. And drill across, it means I want to cross not only from the product, but across from the other perspective. So maybe the in the data warehouse, you can see with the star or the Snowflake schema. Okay, if the schema has not available for all the attributes, then we can also drill across the product with the client. So I know that the product is 40 and I want to drill to the client information. 5 is belong to client 1 and 35 belongs to client 2. So something like this one. Because I have the information like the product and the time and the location, but I don't have information about the client. So we are going across from the component in the data warehouse. Or we have the drill through. So drill through means the summary report to a detailed report showing the revenue breakup for by product line. Let's say if it is like the information, the total sales in America. So I want to see the details, this one, is the total from the camping equipment, golf equipment, mountaineering equipment, outdoor, and personal accessories. So you can also drill through again this information from the other items. Okay, so usually the drill through and drill across is correlated with the measure. In order to understand about the whole concept again, we need to understand also the StarNet query model. In the StarNet query model, it means for every the dimensional table, okay, or we have the dimensional table and the fact table at the same, we have the information for everything. Let's say I have the time, okay, so the time I want to check what is the time that you want, annually, quarterly, or daily, and then the shipping method. So it is the categorical, if I want to see if I want to ship this on the truck or the air express. And then the customer orders, what is the type of customer orders, whether it is a contract or it is an order. Okay, and also the customer, I want to see who is the customer, product line, or the product group, or product item. Okay, and then also about the organization, who made this business, who made this sales, whether it is a salesperson, or it is based on the district, or it is based on the division. Okay. So this one, it means every circle, you call it as a footprint. So the footprint here can be connected each other, and if you know this StarNet query model, then you can easily get the data from the data warehouse. Let's say, okay, I want to know the customer order with is a contract, and then I want to check based on the product group, and then I want to know the district where the shop is located, and I want to know where is the district country, and then let's show the quarterly basis and show also the shipping method for the customer. Then those things can be queried in one sentence in the database. And you want to browse, yeah, usually in the data cube, yeah, you can do the visualization, and this is the visualization, and those cube can be seen directly. If the cube is like quite high, okay, then maybe this product is having a lot of sale, or this one shows a potential buyer. Okay, so it is in the North America, or maybe this one is Europe. Okay, maybe the small one, because it is not it is a cool sport line, maybe it's not that famous, so the Europe market is low. So using this data cube visualization, we can directly indicate something. And then you want to see more detail in this location and in this product and in this revenue stuff. Then you want to get this one, and then later, after you extract this data, you want to use this one for the analysis. That's also possible. Okay, so learning check. How many dimensions are there in data warehouse? You still remember how many dimensions? And then how many measures are there in data warehouse? Yes, you still remember? And can you mention the typical OLAP operations? There are 5. Okay, so please review. Okay, so how many dimensions in the data warehouse? You can see there are, yeah, those we call as the dimension. We call this is the dimension tables and the fact table. So at least there are 2 dimensions for the data warehouse that you can use for the remaining schema. Okay, so in the we call it the dimension is this one. So the dimension is the star schema, Snowflake schema, and fact constellation. So this is the connection between the dimension tables and the fact table. Okay, this is the dimension. Okay, one more time. This is the dimension of the modeling data warehouse. And what are the measures? The measures, this one, yeah, the measures. We have distributive, we have algebraic, and we have the holistic. Okay. There are the data, the Snowflake, Starflake, and fact constellation. What about the measures? We have the holistic, we have the distributive, and we have the algebraic. And can you mention the typical OLAP operations? Yeah, we have the drill down, drill up, roll down, roll up. We have pivot. We have the drill across, drill through. Okay, those kind of thing you need to understand. And maybe the term is a little bit difficult for you, but at least you understand the basic idea behind that concept. Okay, I think I will stop here, and thank you very much for your attention for this video, and hope you enjoy your holiday for Chuseok. Thank you very much. Keep healthy.